Ohm's Law Lab, we're also going to be investigating a more complex circuit. And so these don't lend themselves to just simple Ohm's Law type calculations. We have to investigate them through what are known as Kirchoff's laws. So I'm calling this a Kirchhoff circuit. It's not that Dr. Kirchhoff had anything to do with the design of these circuits, but he allowed us to analyze them. For instance, all these different pathways that you see, he gave us a couple of formulas to help us figure out, for instance, how you could calculate the current that runs in any one of these parts, because it's going to change. So let's take a look at this crude drawing of mine and see if we can reproduce this drawing physically. So we have batteries, that's the long and the short. I've called him V1, another battery source V2, or it could be the variable power supply, depends on what you want to use. Positive end of the battery, negative end, so the polarity is important when you're building your circuit. A couple of resistors thrown in of given values. And then let's say that we wanted to actually measure the current. Then the A with the circle, that stands for ammeter, at this location. How would you go about building this circuit? Well, number one, if we're using batteries and we're using the individual resistors, it's going to take a lot of gator clips. So you'll be doing that. But the other rule of thumb is that you want to use as little bit of wiring as possible, because we saw that wiring does contribute to the overall resistance. So let's get a feel for how we might do this. So we have a couple of batteries. Good idea to just kind of line them up, give you an idea of where they're located. And then you have a couple of resistors, and you have your multimeter, which is going to function as an ammeter. So how could we connect all these up with one another with keeping these with the right polarity, negative on one side and positive on the other? Well, we want to pick a point somewhere. I'm going to start with the meter itself. And let's say that we want to plug in to the meter. Okay, so that this part here, he'll eventually run up to this battery, and this part here will find its way somehow to these resistors. So let's consider this part right now. Right? So this is known as a junction or a node, which means that we're coming out of the meter. That means that we're going to want to split to one resistor and to another resistor. Now we could do that, from here, attach two more wires and then head these directions. But instead of doing that, what you could do is attach two directly to the meter itself. And now one of these can go to one resistor and the other can go to the other resistor. Now here's where we're going to need gator clips. So we're going to clip on here. So we're going to clip to one. Clip to the other one. And so what you've done so far is you've built the bottom part of the circuit. Now, what we're going to want to do here is, let's look at the other side. We're going to want to clip into the battery. So let's do that very thing. So now we have this part of the circuit. And we see that this resistor here, which matches here, we're going to want to go into this battery over here. So that requires another gator clip on each side, one coming out of resistor number 2 and going into this battery. So we're coming along fine. Now what we want to do though is we want to go out from this resistor, and somehow we need to link up to both of these batteries. So there's a couple ways we could do that. Well, let's go ahead and attach a lead to the other end of this battery. And so that would represent, let's say, this part right here. So the question is, well, what are we going to do at this point? Well, let's go ahead and connect to the other end. Okay, so what we now have here is we have another junction point. So what we could do now is we could tie these two together. Alright, so what he's doing, he's coming from this top right battery, and this guy's coming from the resistor in the middle, and so that acts as your node, which can now, we can go ahead and attach to the other battery itself. Not very pretty, but just logically you reason it out, and this will help you use a minimum amount of wiring. And so we're all set to go. Let's go ahead and while we're here, check the current, and you should always check the current with the 10 amp setting like we said before, which would mean that we should be plugged in over on this side. But I've already checked it before, so I know it's less than 200 milliamps. So if I dial to 200 milliamps, we see a reading that's indeed less, 118 point, and a little bit of variability in that last decimal. After all, that is just a very small amount. Looks like it's settled down to 0.2. Notice the minus sign. What that would mean is we really have this linked up backwards. And so this being the negative end of this battery, what you always want to do is link up with the negative end of the meter itself. So that would mean we would really want to reverse this polarity. And that being the case, you see we get the same reading, but with the positive. And so we could test. So what we've done is we've built this circuit right here with the ammeter at this location, but we could move the ammeter around. Like maybe we might want to check over here or check over here and whatnot. And so Kirchhoff's rules will give you a way to analyze how all that works. And even another twist would be we could take one of these batteries and reverse the polarity, for instance. So Kirchhoff's law.